problems off the homework. Can you see that red, or do I need to change it to a different color? Can you see that?
Sort of. How about green?
I don't think green would show up.
Okay.
Probably do like a white maybe. Is that better?
Yeah.
Questions, problems you want to see worked? Just tell me off of any of the pages. Again, we're going to try to hurry because we don't have as much time. So,
Page 181, 26.
181, 26. Remind me here in a minute. 181, 26. Tristan, I'm gonna hurt your feelings. Be quiet. Got triangle GHJ. Got to make sure you're drawing these pictures. Now, when I draw that triangle, it looks like an equilateral triangle. Is it an equilateral triangle?
I drew
No.
mine. Like I labeled mine.
That's all right. If you drew something, you drew another triangle, maybe you GHJ or something like that. It doesn't matter how you label a triangle, because whichever order you go in, it's still going to be the same. Because you can't jump opposite corners or anything else. So when you name this triangle, little triangle symbol, GHJ, remember it goes out front. It doesn't really matter, as long as when you label the stuff that they tell you, that's going to make a difference. Now it says it's isosceles. What's an isosceles triangle? All right, it's got at least two sides that are congruent. And they tell us that those two congruent sides are segment HG and segment JG. So we know that those two are congruent. Then they give us a whole bunch of other information that we're going to write in here. They say that segment GH is x plus 7. This is stuff you have to do. This whole chapter, you've got to go through and label everything. If you don't go through and label everything, you're not going to understand most of these problems. So you go through and you label this side x plus 7. Go through and label GJ 3x minus 5. Before I go any farther, what equation can we set up just from that first part of that information? X plus 7 equals 3x minus 5. We know that those two are equal to each other because they told us that those were the two congruent sides of the isosceles triangle. Notice I did that before. They told us some more information. This side down here is x minus 1. I did it before that because as soon as you write in x minus 1 here, what's that do? People think this, x plus 7 plus 3x minus 5 plus x minus 1 equals how much, David? 180. The bad thing with that is totally and completely wrong. What of a triangle adds up to be 180? The three angles, not the three sides. Please don't do that. All right? Make sure you don't do that. The three sides, do they have to add up to be anything special? No. Another problem that a lot of people would have once you label all three of them is some people will say, well, I want to do this. X plus 7 equals x minus 1, because this one's easier than that one. Are those two equal to each other? No, we don't know that, so you can't do that either. You got to the two that you know are equal to each other, congruent to each other. Those are the ones you got to set up the equation with. Now we go to solve this. How do I start to solve this equation? Minus the x on both sides. Get all the x's on one side. Good.
7 equals 2x minus 5. Then you add 5 to each other.
Add 5 to both sides. 2x equals 12.
Then divide by x.
Divide by.
Yeah.
2, what's x equal?
6.
So x equals 6. Is that our answer? I don't know, because I didn't finish reading the problem, did I? I didn't read the directions. Find x and the measure of each of the sides. So we did find x, so that's part of our answer. X equals 6. Got to plug it back into each side. What's 6 minus 1? So segment HJ equals 5. What's another side that we need to find? HG. Plug in 6 right there. What's 6 plus 7? 13. And then the last side is GJ, right? Do we have to plug in there to find GJ? How can you find it? It's the same as that one, isn't it? They were congruent. Those are our 4 answers. Those kind of problems are what we're going to do the most of. As a matter of fact, if you remember on the semester exam, there was a problem on there that was sort of like that. Guess where that problem came from? The chapter 4 test. Remember I told you all the questions on the exam were from old tests? Well, the chapter 4 test wasn't an old test because we hadn't taken it yet, but it was one of the exam problems. Next question. Which one? 32? Same, is that on the same page? Okay. 32. Find the measure of the sides of triangle ABC. Classify the triangle according to its sides. And they give us, this is problem 32, they give us some coordinates here. So I'm going to draw coordinates. Let's see, 5, 4. I know my coordinates aren't going to be exact. That's A.
What? Go ahead.
3, -1. What's going on with my pen? That's B. And 7, -1. That's C. So we have that triangle. Again, do we just look at it and say, hey, that looks like an equilateral triangle? No, especially not with the way I draw things. Now, nice thing about this one, we want to find the length of each side. Segment AB, segment AC, and segment BC. BC is probably the easiest one. Look at this. What's nice about segment BC? What special kind of segment or line is it?
Straight.
All lines are straight.
180.
What's,
Vertical, horizontal.
which one is this?
Horizontal.
If it's horizontal, all we got to do is count, right? Look, the y's are the same, -1, -1. Then all you got to do is count from 3 to 7. How many spaces do you go from 3 to 7? 4. So how long is segment BC? 4. Now the other two aren't quite that easy. What do you got to do to find the distance from A to B? Use what? The distance formula. Distance formula, remember, you subtract the x's, square it, subtract the y's, square that. Somebody have their calculator out to help us here in a minute. For AB, what's our x coordinates? 3 and 5. So 3 minus 5 squared. What's the y coordinates? Okay, let's go the other way. 4, -1. It doesn't really matter, but I don't want to confuse it. 4, -1 squared. What is 3 minus 5?
-20.
-2 squared.
-22. That's what it said.
negative,
No,
it's not negative, is it?
It's
Positive 4.
then.
Here we can change those both to plus. What's 4 plus 1? 5, 5 squared, 25. 4 plus 5, 29. Don't forget to take the square root when you get down here to the bottom of it. All right? Is 29 going to come out even? No, so somebody figure out what that is.
2.3.
Nah, that doesn't sound right.
5.3.
I'm lost, okay?
5.3. Grab your calculator,
I did that though.
hit square root 29, then hit equals.
5.3.
You had something extra in your calculator you forgot to clear out before you. So this side right here is 5.3. This side down here was 4.
Yeah.
Now we gotta do this side. Let's try to do this one a little quicker. What's our x coordinates this time?
5 and 7.
5 and 7. What's 5 minus 7? Negative 2. Negative 2 squared. Four minus a negative 1. Be careful. What's going to happen there? Positive. What's 4 plus 1? 5 squared. 25. Any of this looking familiar? Gives you 29. What's the square root of 29? 5.3. So we found all the sides, lengths of all the sides. Then they ask us to name this triangle according to its sides. Well, what kind of triangle is this triangle? Isosceles. It is an isosceles triangle. It's an isosceles triangle. Gotta be able to do it that way. Levi got it right. I hope he just didn't get it right by guessing.
No, I did yours.
Other questions?
Why are you looking at me like
If you don't know your mouth, ask a question. If you got a serious question, if you don't know, then you better ask a serious question.
I was confused on 189 and number 12.
189, number 12.
Oh, yeah. That's good, man.
189, number 12. Let's see. I'm not drawing the ice cream cone.
Why not?
That's probably why you're having trouble understanding them, Chloe.
Okay.
Because you can't look past the ice cream cone.
You went to ice cream.
I ate ice cream this morning.
What's that tell us? Those two angles are the same, right? If those two angles are the same, this angle's 39 degrees.
That's 70.
How can we find those two angles? Say it again.
180. 180 minus
180 minus 39. Good. Borrow. It's 1, 4. Is that right? 1. Now, does that mean this angle here is 141?
No.
No, what do you got to do? Divide that by 2. 141 divided by 2. 0. I have to bring down a, put in a decimal, bring down another 0. 2 will go into 10 5 times. So what is it? 70.5. So that angle is 70.5 degrees. What's that angle? 70.5 degrees. Other questions?
18.
18? All right, with the problem with like 18, then we'll do a lot of these problems this chapter. Give me a minute. I'm going to draw the picture up here, and I won't do problem 18. I won't find the measure of angle 1 for you, but what we will do is go through and find all the angles that we can find in the picture, and then you can go back and answer the questions yourself, right? So give me just a second to draw this picture.
I'm just glad I don't want to
Do what?
do that.
Does that look pretty close? Did I miss anything?
That's good enough.
63. I'm not gonna be able to do this on the side. Angle 2 is here. Tell me if I label something wrong. Let's even put a number up here. Well, don't we have 7? That way we can find every angle. Which angle do you want to try to find first? Do you always have to start with number 1 to find it first? No, don't do that. That's why I'm not doing that. You want to do 6 first? How do you find angle 6?
180
David's backwards today, isn't he? You're always tired. So what's the measure of angle 6 there? 44 degrees. Now what? 7? They did tell us this. They told us that angle 4 and angle 5 were congruent. I forgot to mark that. Angle 7 we can find. 3 angles of a triangle have to add up to be how much? 180. So 47 plus 44. 191. Subtract that from 180. Got 7, 9. Borrow here. 89. Is that right?
Yeah.
So that angle's 89. Now what? 2? How are we gonna find angle 2? Find what? Oh, okay, so we go back to angle 1. How do we find angle 1? What do you know about these 3 angles here? They gotta add up to 180. So we add these 2 together, subtract it from 180, it should leave us with angle 1, right? 69 plus 47 is 6, carry the 1, what's that, 116. Subtract that from 180, borrow, that's 4. 64, is that right? So that right there is 64 degrees. Which 2? So these 2, 63 plus 64. Got another triangle right here, right? That's 127, subtract that from 180. What's that give us? 53. So angle 2 is 53. Now what? We still got 3, 4, and 5 to find. What do you know about angle 3? That's true, it's obtuse. Now be careful, is it vertical to that 69?
No.
It's actually vertical to that angle. Well, how could we find that whole angle? 69 plus 47, didn't we do that somewhere? 116, so what's angle 3? 116. How can we find 4 and 5 now? We just did it on that other problem a minute ago. They're congruent, so you do 180 minus 116. Didn't we already do that somewhere too? 64 right there next to it. Does that mean each one's 64?
No, each one's 32.
64 divided by 2, what is that?
32.
So this angle's 32, that angle's 32. We found every angle in the picture except for this one. Anybody tell me what that angle right there is? 64. Should you be able to answer every question on this page about that picture then? And do that. They're gonna try to confuse you sometimes. We might have been able to find angle 1 right off the bat there, but could we find angle 2 next? Maybe. But some of the other angles, you might not have been able to find them all in order, all right? So don't go through and just try to find each angle in order, because then you're gonna get stuck and not be able to do it. We jumped clear to angle 6, which was the last angle that they had numbered, and found it first because it was easiest. Do that. Find the stuff that's easiest, then start finding the other stuff. Can you go through and pick out all the answers then? What was the answer to 18? 19? 20?
117.
1 what?
116.
How do you get 1 degree off the answer?
I don't know.
Other questions? Yes, no, maybe?
What?
Other questions?
No. How about you? Yeah.
Nope. All right, what I want you to do on that worksheet, I'm going to give you about 5 more minutes. Again, focus on this side. All right? Focus on this side. Here in 5 minutes, no more than 5 minutes because you had some time previous, I'm going to collect it. 3 of the problems on that worksheet, if you were paying attention up here, you've probably seen the 3 problems because I kept flipping back to the wrong slide about 10 times. 3 of the problems off that worksheet are going to count as a quiz.
Which ones?
I'm not going to tell you.
Look, that one's 140.
So help each other, try to get it. Focus on that one side, get as many problems done as you can. Ten oh three right now, you got till 10:08.
Yeah, look, this one plus the,
Two triangles are congruent to each other. When you're proving 2 triangles are congruent to each other, you're using those 6 parts. Now, you don't actually have to prove all 6 parts of one triangle congruent to all 6 parts of the other triangle. There's shorter ways, and that's what we're going to talk about. Those shorter ways. It's on the right slide next. Maybe it is right one. All right, definition of congruent triangles. You probably can't see that, can you? Can you see it? Definition of congruent triangles. 2 triangles are congruent if and only if their corresponding parts are congruent. So in other words, in this picture, angle A would have to be congruent to which angle? Angle F. Angle B would have to be congruent to which angle? D, good. Angle C would have to be congruent to angle E. Now that's part of the parts. What else do we still have to show are equal to each other, congruent to each other? The sides, the segments. AB would have to be congruent to what? AC would be congruent to, and BC would be congruent to. All right, so that's what makes 2 triangles congruent, when all those corresponding parts match up. When all those corresponding parts are equal to each other. Again, corresponding means if we take those two triangles, lay them one over top of the other, corresponding are the parts that lay on top of each other. So angle A would lay on top of angle F. Segment AB would lay on top of segment FD, so on, so on, so on. Now again, we don't need all of that to prove that these two triangles are congruent to each other. And that's what we're going to go through and do. We don't need all of it. All right, the way congruency statement is written is important. What I want you to draw here is just, is just this picture I'm getting ready to draw. I don't know, give me some letters. Let's name this triangle. Say it again. A, B, C? Thought maybe you'd be a little more creative. You should have, now you can't because you already used the A. Unless you spell it wrong. Give me a way to name that second triangle. Yeah, you gotta be different letters. G-E-F. Now, when we show the congruency, what the congruency is when you say this triangle is congruent to this triangle. When you show that congruency, and that's what we're going to write down here, the things that are congruent have to match up. So the way I have them drawn, it looks like, we'll just name this first triangle, triangle ABC, doesn't matter. When you name the second triangle, it doesn't matter how you name the first triangle, but when you name the second triangle, you have to match it up the correct way. So A over here is going to match up to what in that other triangle? G. B over here is going to match up to what? And then C over here is going to match up to what? So when you write that congruency, that's what this is right here. That's called the congruency statement. When you write that congruency statement, you have to make sure you match up the two triangles correctly. So let's do this in, what if I said triangle BAC? How would you have to name the second triangle? Good. All right? So you've got to be able to switch them and make sure that you match them up. Keith, that make any sense? Match them up. Now, when you are matching them up, that's not what I wanted. When you are matching them up, all right? Sometimes you'll have to do one of three different things to it. And this is what we did in chapter 9, way back towards the start of the year. Sometimes you might have to flip the triangle. When you flip the triangle over, does that change how the triangle is? No. Doesn't change the size, all right? Sometimes you might have to flip it. Sometimes you might have to just, like we did on this one, just slide it. Sometimes you might have to, what's the other one? Turn it. Rotate it. What's the one of the transformations that we talked about that we're not going to use there? Dilation, because what's a dilation do? Makes it bigger or smaller. Changes the size. All right? So sometimes, you may have to rotate it around, turn it. Sometimes you might have to flip it over. Sometimes you just slide it to get them to match up. But you're always trying to get them to match up correctly. You got to make sure you match them up correctly. All right, go ahead and write these three things down. Skip a little space. We've done this like 5 times this year, right? I'll tell you what, you don't even really need to skip any space in between them because we're just going to write one thing out here. We dealt with these properties earlier this year. We dealt with them for algebra. We dealt with them for segments. We dealt with them for angles. Now we're gonna deal with them for triangles. Theorem 4.4 says reflexive property, symmetric property, and transitive property all work for, what do you think this one's gonna say? Triangles. All three of those properties work for triangles also. Now, just real quickly, we'll write down, does anybody remember what the reflexive property is? I hope so, because this one's very important in this chapter. Anything equals itself. Anything equals itself. So segment AB equals what? Segment AB. Angle Q equals what? Angle Q. That one's very, very important. The other two, we don't use a whole lot with triangles. Anybody remember what the symmetric property says? If, we'll just use A and B here. If A equals B, then the symmetric property says what? Then B equals A. Just turns it around. So in other words, if you had two triangles, and triangle ABC was congruent to triangle DEF, is that what we had on that other one? GEF? Yeah. Then what could I do with these two triangles? Could just flip them around and it'd still be true. Transitive property, anybody remember that? A equals B and B equals C, then we know A and C have to be equal. So that one would say something like if we had these two triangles were equal, and then we knew triangle DEF was congruent to triangle PQR. What can you tell me about triangle ABC? It's got to be congruent to what? PQR. That's what the transitive property would tell us. Again, we don't use these two very much when we're dealing with triangles. This one, we use a bunch. Not so much for the triangles, but for the segments and the angles that are parts of those triangles. Because if I draw something like this, how many triangles in that picture? Close. There's three, right? These two look like they might be the same as each other, might be congruent to each other. Well, those two share a side, which is AC. So I know that segment AC in the triangle on the left has to be congruent to segment AC in the triangle on the right. And how do I know AC is congruent to AC? By the reflexive property. All right? And then some you could even have, see if anybody can pick this out, if I can draw it. We got that triangle. We got this triangle. Anybody tell, what do those two triangles share? An angle. They share this angle right here. Well, that angle in the white triangle has to be the same as the angle in the red triangle, and our reason would be the reflexive property, because it's the exact same angle. All right? That one's a little harder to pick out. This one here, I use a bunch. Because you should be able to pick that out. Hey, they share a side, so that's going to be one side that we know. All right, proving that triangles are congruent. Go ahead and write these down. These are 4 shortcuts. These are the 4 shortcuts that we're going to use to show that two triangles are congruent. Not really. I mean, you need some space out to the side because it's gonna take a little bit of writing, but not a whole lot. So these are ways to prove two triangles are congruent to each other. As soon as you hear the word prove, what do you think we're gonna be using a bunch of again? Two-column proofs. Now, these two-column proofs, when you're dealing with triangles, I think are a whole lot easier than the two-column proofs that we did earlier in the year. Because, David, you see this right here, SSS? That's giving you, like your blueprint, what has to go in your two-column proof. It's telling you got to prove a pair of, anybody know what S stands for? Sides, another pair of sides, and another pair of sides. So to prove two triangles congruent, the first one here, side, side, side. Which one don't you see up here? Angle, 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 that's one of them. So please remember, angle, angle, angle doesn't work to prove two triangles are congruent. All right? What's another one you don't see up here? Side, side angle doesn't work. All right? That's the Levi postulate backwards. Right, Levi? Did you get that? Yeah. All right. So those two don't work. These are the only four that work. So if I give you two triangles, we're trying to prove that they're congruent, maybe we know this pair of sides. So that's one pair of sides. Is that enough to say that they're congruent? No. Then maybe we know these two sides are congruent. Is that enough to say that two triangles are congruent? No, right now we have a side and a side. What else do we need? A side or a angle. Now, with the angles, with these two, right here, this angle, you probably need to write this down somewhere. This angle right here has to be the included angle. What that means is in the picture, it has to be between the two sides. So which angle would it have to be? The top one. All right? And it'd have to be the one that matches up to it down there. So that has to be the included angle. Guess what has to be true about this side right here? Has to be between the two angles. Has to be the included side. Has to be between those two angles. Now, it doesn't make as much difference on this one, because if the side's not between the two angles, then it ends up working with angle, angle, side anyway. Included just means between. So it has to be the angle that's between the two sides that you know, or the side that's between the two angles that you know. Tristan, that make any sense? That? I couldn't hear you. What could you use on this first one to show these two triangles are congruent? Side, side, side. Let's do this. Those two are congruent. Those two are congruent. Can everybody see that? Side angle side. How about this? That angle is congruent to that angle. That side's congruent to that side. That side's congruent to that side. Angle side side, side side angle. What'd you guys just tell me? That one doesn't work. Does this one work?
No.
No, it's the same as that one, just backwards, right? Can we prove that those two triangles are congruent to each other? No. So these are not congruent. Couldn't say that they're congruent. All right, here's your assignment. It's not a real long assignment with 4, 5, 9 or 10 problems. On any of them that are 2-column proofs, if they say write a 2-column proof, we'll go over quite a few of them next class. If they say write a 2-column proof, the first thing you got to do is write the problem down. So write the given and what you're trying to prove, and draw the picture. Draw whatever the picture is that they give you. So do that on every 2-column proof.
Shut it, Robbie. You're bad, shut it.
Please make sure you get the assignment down because I don't have it on Moodle yet, I don't think.